friends, welcome to my channel Maths Practice. In the last video, we had discussed some key concepts of real numbers, which are the Euclid's lemma and the fundamental theorem of arithmetic. Today, we are going to discuss the remaining key concepts of the chapter real numbers and important practice examples. Next is the decimal expansion of a rational number. We know that a rational number can either have terminating decimal expansion or non-terminating decimal expansion. Now, if it has a terminating decimal expansion, it can be written in the form of x is equal to p upon q, q not equal to 0, p and q are co-prime, where q is of the form 2 raised to m into 5 raised to n, where m and n are non-negative integers. For example, 0.375 can be written as 375 upon 10 raised to 3. Now we can see the denominator can be written as 2 raised to 3 into 5 raised to 3, which is in the form of 2 raised to m into 5 raised to n. Another example is 13 upon 125. It can be written as 13 upon 5 raised to 3. We multiply and divide it by 2 raised to 3. So now we can see that the denominator can be written as 2 raised to 3 into 5 raised to 3. Hence, it has a terminating decimal expansion. Now, if it has a non-terminating decimal expansion, it cannot be written in the form of 2 raised to m into 5 raised to n. Q cannot be written in the form of 2 raised to m into 5 raised to n. For example, 7 upon 30. It is 7 upon 2 into 3 into 5. So, it is not in the form of 2 raised to m into 5 raised to n. Some examples. State whether following rational numbers have terminating or non-terminating expansion. 17 upon 8 can be written as 17 upon 2 raised to 3. Multiply and divide by 5 raised to 3. So we get 2125 upon 10 raised to 3, which is 2.125. So it has a terminating decimal expansion and we have written it in the form of 2.125. Next one is 64 upon 455. It is 64 upon 5 into 7 into 13. So the denominator is not in the form of 2 raised to n into 5 raised to m. So it has a non-terminating decimal expansion. Second example, decide whether following are rational or not. If they are rational and of the form p upon q, what can you say about the prime factors of q? The first one is 43.123456789. It can be written as 4312345678 upon 10 raised to 9. So the denominator is in the form of 2 raised to 9 into 5 raised to 9. That means denominator is equal to 2 raised to 9 into 5 raised to 9, where m and n both are 9. Next one is 43.123456789 bar. So it has a non-terminating and repeating decimal expansion, since it cannot be written in the form of 2 raised to m into 5 raised to n. So this is an example of non-terminating and repeating decimal expansion. Friends, let us solve some practice examples which will cover all the key concepts of the chapter. First example, find the LCM of 510 and 92. Using it, find the HCF. Now you know how to find the LCM. We have found the LCM of 510 and 92. And it is 2 into 2 into 5 into 3 into 17 into 23, which is 23460. Now there is a result that if n1 and n2 are two numbers, then its HCF into LCM is the multiplication of the two numbers. So if we have one of them, we can find the other. HCF of these two numbers will be the multiplication of numbers 510 into 92 upon its LCM, which is 23460. That is equal to 2. So we have found the HCF equal to 2. Second example is find the largest 3-digit number that is divisible by 3 and 5 both. Now since it is divisible by 3 and 5 both, it should be divisible by 3 into 5, that is 15. 3-digit number, the largest 3-digit number is 999. So 999, when we divide by 15, we get the remainder as 9. So if I take out 9 from 999, then it will be exactly divisible by 15. Hence the largest 3-digit number that is divisible by 3 and 5 both is 999 minus the remainder which we have got 9. that is equal to 990. Third example, explain why following are composite numbers. First one is 7 into 11 into 13 plus 13. We take out 13 common, so we get 7 into 11 plus 1, that means 13 into 78, which is 13 into 2 into 3. So we have got the prime factors, which is 2 into 3 into 13 square. So it is composite. Since it has more than 2 prime factors, it is composite. 3 into 5 into 7 plus 7. Again taking out 7 common, we have 7 into 16, which is 7 into 2 raised to 4. So this is also a composite number. Next example, find the largest number that divides 533 and 211 and gives the remainder 4 in each case. Now we want the remainder 4. That means if I subtract 4 from both the numbers, then I should get it exactly divisible. 533 minus 4 is 529 and 211 minus 4 is 207. Now I find the HCF for both the numbers. First of all, 529 is 23 into 23 and 207 is 3 into 3 into 23. So the common factor HCF is 23. Hence the largest number that divides 533 and 211 and gives a remainder 4 in each case is 23. Example 5. The length, breadth and height of a room are 8 meter 25 centimeter, 6 meter 75 centimeter and 4 meter 50 centimeter respectively. Determine the longest rod which can measure the 3 dimensions of the room exactly. Since we want to find the longest rod, we know we need to find the HCF. Now we convert it in the form of centimeter. So length is 825 centimeter, breadth 675 and height is 450 centimeter. We need to find the LCF of all the 3 numbers. So we have found the prime factors for all the 3 numbers. 825 is 3 into 5 into 5 into 11. Similarly 675 and 450. Now the common factors are 3 into 5 into 5. That means the HCF of all the 3 numbers is 3 into 5 into 5, which is 75 centimeter. So the length of the longest rod which can measure the 3 dimensions exactly is 75 centimeter. Example 6. Can the number 4 raised to n, when n is a natural number, end with the digit 0? Now suppose if 4 raised to n ends with 0, it must have 5 as a factor. But 4 raised to n is 2 square raised to n, which is 2 raised to 2n. So the only prime factor is 2 here. By fundamental theorem of arithmetic, the prime factorization is unique. So since it does not contain 5 as a prime factor, 4 raised to n can never end with 0. Now some more examples are given in assignment. In case of any query, you can write in the comment section. Hope this video was useful. Please do like, share and subscribe to my channel Maths Practice for more videos on other maths topics of class 10. Thank you.